Hi, David Can here with another question from the question bank in the style of what you find in your Hayes and Harris Math SL textbook, Chapter 3G. In this question, we're given a function. It's an exponential function, and I know because my variable x is in the exponent. Part of the function is shown below. This looks like a normal exponential curve. And I know that the y-intercept is right here at the coordinate 0, 13. First, I want to show that a must be 10. Okay, now x is a variable, f of x is a variable, a and k are constants. And from this information, I'm meant to be able to figure out that the constant a is 10. So let's start with what I know. I don't know the value of k, but I do know that when x is 0, f of x is 13. I know this from this coordinate right here. I can take these, plug into the equation, see where that gets me. F of x then is equal to a e to the k x plus 3. Now k is a variable, it's an unknown. What about e? E is something that we haven't studied yet, or at least I don't think we have. What we need to know for now, though, and what you're going to learn in detail later, is that e is a special character that we use for a very special number, but it is a specific number. It's not a constant, a general constant. It is a number. We know what e is. 2.71 something, 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 something. It's that one number. So it's not unknown. We know it. Your calculator knows it. We can rely on what it is. And most importantly, it's not 0. Because it's not 0, k times 0 is 0, and e to the power of 0 is 1. Anything to the power of 0 is 1 except for 0 to the power of 0, and e is not 0. So that whole thing simplifies to 1, which means that 13 is equal to a plus 3. Subtract 3 to the other side, and we get a is equal to 10, which is what we want. Part B says that given that f of 15 is 3.49, find the value of k correct to 3 significant figures. So we're going to need to use our calculator. That's our hint, that we need to do this with the calculator. So let's do it with a calculator. I know that when x is 15, f of x is 3.49, which allows me to say that 3.49 equals a e to the k x plus 3. Now once again, I know what the value of e is, and so does your calculator, which means that this is actually a one-variable equation that we need to solve for k. Solving this for k, I could try and get things to the same base, but that's going to be crazy. That's not going to work. I could use logarithms, but I have my calculator. Why bother? Let's use the calculator. This is a one-variable equation. There's only going to be one solution for k. There's nothing in here suggesting multiple solutions. It's just a single straight curve. It doesn't flip around or do any loops or anything crazy like that. So I think I can get away with nsolve. So let's use nsolve. Pull up a calculator tab. We're going to nsolve, numeric solve. We're going to solve 3.49 equals 10 times e. How do I get e? Let's take a look at the keypad. Oh, it's right there. E. Well, it's used so much they gave it its own button. Cool. E to the power of k times 15 plus 3. That's my equation. Calculator knows what e is. It doesn't know what the variable in this equation is, though. So we have to tell it, comma, here's the next thing you need to know, calculator. The variable that you need to solve for is k. And that's the complete expression for nsolve. The equation you want to solve and what the variable is in the equation. You press enter. And there's the answer. K is negative 0.21062. That's all of that. Except, correct to 3 significant figures, k is negative 0.201.